Welcome back to Chapter 4 of our Data Communication course. This session 2 where we will explore the LAN technologies, specifically the evolution of Ethernet standards from the original 10 megabits per second specification through fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. In our previous session, we examined LAN connecting devices. Now we will focus on the actual technologies that define how data travel across these networks, understanding their cabling requirements, distance limitation, and key specifications. Let us begin with the evolutions of Ethernet standards. Ethernet was originally designed by X-Rose in 1976 and has since scaled dynamically to meet explosive business demands. It was standardized by the IEEE 02.3 and runs on a shared datagram architecture. Ethernet functions seamlessly across both the physical and data link layers of the OSI model, making it one of the most versatile and widely adopted networking technologies in the world. From these humble beginnings at 10 megabits per second, Ethernet has evolved through multiple generations, each offering high speed and greater capabilities while maintaining backward compatibility with previous standards. Now let us examine the original standard of the 10 megabits per second Ethernet specification. These are foundational standards that established Ethernet as the dominant LAN technology. The first is 10-base-5, which uses a thick coaxial cable, also known as thicknet, and supports a maximum segment range of 500 meters per segment. This was the original Ethernet standard, sometimes called the thick Ethernet. The second is 10-base-2, which uses thin coaxial cable or TNET and supports a maximum segment range of 185 meters per segment. This was a more flexible and less expensive alternative to thicknet. The third is 10-base-T, which uses a Cat3 or Cat5 unshielded twisted pair or UTP copper cable and support a maximum segment range of 100 meters per second. This standard introduces the use of twisted pair cable in star topology, which became the dominant configuration for Ethernet networks. The fourth is 10-base-FL, which means the multi-mode fiber optic links and support the maximum segment range of 2000 meters per segment. This brought the advantage of fiber optic, including immunity and electromagnetic interference and long distance to Ethernet networks. As business demand grows, the need for high speed becomes critical, leading to the development of fast Ethernet. The 10-base-TX standard operates at 100 megabits per second, utilizing the Cat5e unshielded twister pair cable wireline. It maintains a strict 100 meters physical boundary and supports speed auto-negotiation, allowing devices to automatically determine the best possible speed for communication. The 10-base-FX standard provides longer physical runs with absolute immunity to electromagnetic interference over multi-mode fiber, and it can reach up to 20 kilometers over single-mode fiber. Fast Ethernet essentially increased the speed tenfold while preserving the same fundamental frame, format, and access method, making it an easy upgrade path for existing networks. Beyond fast Ethernet, the industry continued to push for even higher performance. The gigabit Ethernet and 10 gigabit Ethernet standard form the backbone of modern cloud database and campus trunks. The 1000-base-T standard support 1 gigabit per second speed up to 100 meters over copper cabling. This allowed organizations to achieve gigabit speed using existing Cat5e or Cat6 cabling infrastructure, making it a cost-effective upgrade. The 10G base LR standard runs at 10 gigabits per second over a single mode fiber for distance up to 10 kilometers. This provides extremely high speed connectivity for long distance links, making it ideal for connecting buildings on a campus, data center interconnects, and metropolitan area networks. These high performance standards have enabled the massive data throughput required by modern applications such as cloud computing, video streaming, and large-scale database systems. To summarize this second session, we have tracked the evolutions of Ethernet standards from the original 10 megabits per second specification to the high-speed standard of today. We explored 10^5 using thick coaxial cable at 500 meters, 10^2 using thin coaxial cable at 185 meters, 10^T using UTP copper at 100 meters, and 10^FL using multi-mode fiber at 2000 meters. We then examined fast Ethernet standards 10^TX over copper at 100 meters and 10^FX over fiber extending up to 20 kilometers. Finally, we looked at the gigabit Ethernet with 1000^T over copper at 100 meters and 10 gigabit Ethernet with 10 G/LR over single mode fiber at 10 kilometers. Understanding these standards, their cabling requirements, and their distance limitation is essential for designing and implementing efficient, high-performance local area networks. In our next session, we will explore the WAN technologies and protocols. Thank you for watching, and I look forward to see you in the session 3.